Hello. They say that the simplest thing in the world is life, and the most complicated is the way we live. In the same manner, I always say in the classes that do you know that the simplest thing in the world to understand is biostats? Of course, life is simple, and the most complicated is the way we learn biostats. That is what makes the whole difference. So anyways, let's get started and welcome to this next chapter on biostatistics. So already you should take a good cup of coffee or tea and get yourself going with the good higher amount of adrenaline and high amount of caffeine in your body so that you understand this roller coaster ride about biostatistics. So let's start with the first point. Why on earth would you study biostats? What makes you study biostats back again after so many years? You were all scared of mathematics, right? And that's the reason probably you chose biology or any other medical branch. So you were scared of biostats or mathematics, and there you are, you're studying biostats again. What makes you study biostats? Let us say Mr. A is there. He has a fasting blood glucose of 120. Mr. B is there. He has a fasting blood glucose of 130. What's the difference between them? How much milligram per deciliter? The difference we find is 10 mg, right? Let us say we are talking of the fasting blood glucose, right? Let us say Mr. X is there and Mr. Y is there. What's the fasting blood glucose of X? Let us say is 90 milligram deciliter, and for Y it is 100 milligram deciliter. What is the difference between these both? Answer is again 10. So that means try to understand that we are all humans. Our innate thing is that we are humans. And being a human will cause a lot of variations. Your all 5 fingers are never same. One finger is small, one finger is big. Your BP is never same. In the morning it is different, in the evening it is different. Your height will be different from your parents' height. Your height will be different from your offspring's height. So everything is varying. That is what makes us human. The beauty of being human is that variation is innate to us. You as a researcher or you as a medical professional or you as a doctor who's dealing with humans should understand, mind the language now, which variation is of importance and which variation is of not importance. If you just see the variations, if you just look around the variations, there is 10 mg deciliter variation and there is 10. But in this scenario, let us say this is the world. You remember from the world in screening of disease. Let us say this is the world and these are some people with disease, with diabetes. So if these are some people with diabetes, in scenario A, the A was from this place and B was from this place, from the disease area. And in the green and the blue thing, both X and Y, they were from the normal zones. So this variation does not mean anything, whereas this variation makes a hell lot of a difference. One person is disease, another is non-disease. So that is first reason to understand the variation. The second reason which you need to remember for your exam is that why would you study biostats? I already told you that. Let us say Mr. A comes, his blood sugar is 120, Mr. B comes, his blood sugar is 130. Will you say this B is diabetic? Yes, maybe you are saying. Let us say I come and my blood sugar is 125. My friend comes, his blood sugar is 127. Would you say he is diabetic? Can you write it on a page and put a stamp on it that yes, this 125 is healthy? Can you write like this? And this 127 is diseased. Is it done? Maybe you are wrong. Maybe you are not. So the second point is to understand the cutoffs. When to say that person is diseased, or when to understand that person is not disease. So that's the utility of biostats. Let's write some MCQs for you. What is the use of biostats? The use of biostats, you just need to understand this. That is the reason I'm building a small base right now. The use of biostats is to define cutoffs. To define when do you call a disease and when would you call a person as normal. Second is to understand variations. To understand variations in data. Third is one very important difference. You need to present data, and that is, I think you must have understood the importance of biostats, specifically talking in COVID-19 infections when you had made the way the data is presented, that makes the whole difference of understanding the gravity of the situation. So presentation of data, when we present to you bar charts or line chart, that this is what is happening in the world. So many people are dying, so many people getting infected, but the good thing is so many people getting recovery. You see those line charts and so many things happening. That is what is presentation of data. In fact, that's a very powerful tool that we use in biostats. So one is understand variation, present data to define the cutoffs, and finally, all said and done, to make final inference. Inference means to find out the evidence that yes, this thing makes a change or this thing does not make a change. So these are your couple of uses of biostats which you would be using. In the session to come, and of course in this module as well, I will be of course talking about biostats quite in detail. We will cover biostats under 3-4 major headings. We will talk about the basics in biostats, where we will talk about the data and the scales of data or the types of data. What is nominal data, ordinal data, what is quantitative data, parametric data, non-parametric data, things like this. And subsequently in the next section, what we are going to deal is about the comparison of data. You want to compare what is happening with COVID-19 in India and what's happening with COVID-19 in US. You want to compare what is happening with dengue cases over here and there. So you're trying to compare different populations, or you're comparing patient A with patient B. So comparison of data of numbers can be taken in 2 sections. We will talk is the measures of central tendency. Central tendency, we will talk about the mean median mode, and we will also talk about the measures of variation, where we will talk about the standard deviations, the standard errors, so on and so forth. At the third level, in the third section, we will of course talk about the inferential stats. Inferential stats. What do you mean by inferential stats? Inferential statistics means we will talk about the p-values. We will talk something more detailed. We will talk about the tests of significance. Something more in detail, we will also talk about the normal distribution curve. Normal distribution curves, these are called as the probability distribution curves. And then subsequently in another last section or somewhere towards the end of the understanding of biostats, you would also be learning something about the miscellaneous topics. Like we will talk about correlations, we will talk about regressions, and a lot of stuff on that, skews, probability rules, and things like this. And of course, we also need to talk about the graphs in biostats, where we will try to see what all graphs are there. So with this understanding, let us begin with the topic number 1 of the day. We'll talk about basics in biostats, data and scales of data. Data. Data means numbers. Data can be probably divided into 2 types. You can have a quantitative data, or we can have a qualitative data. Let us say that I talk about the number of boys in this class and number of girls in this class. Let us say there are 30 boys in the class and there are 40 girls in the class. Let us say I talk about number of people wearing blue shirts, number of people wearing red shirts. There are 10 people wearing green shirts, 10 people wearing red shirts, 10 people wearing blue shirts. Let us say I talk about the weight of the class. Let us say that the weight, your weight, first is let us talk about your weight, then I'll talk about the class. Let us say your weight is 50 kgs. Your friend's weight is 60 kgs. My weight is 80 kgs. Somebody else's weight is 70 kgs. Now, the number of students in the class will be 30 boys and 40 girls, but the weight can be 50 kg, 60 kg, 70, 80. But weight can also be 50.1 kgs, weight can also be 50.12, 123, 1234, whatever decimal numbers. But the number of boys in the class, they cannot be 30.32 boys. It's not done. Nobody would accept that. So the number of boys in the class has to be some kind of jumping numbers, 31 boys, 32 boys, 33 boys, or it can be 40 girls, 41 girls, 42, but the weight can be 40 kgs, 40.1 kg, 40.12 kgs. So that means there are 2 types of numbers. If you see from biostatistician eyes, we see numbers in either 2 forms. Either these numbers will be running numbers, that means whatever scale you can take, or these numbers will be hopping or jumping numbers, that means they are discrete numbers. So usually we say that numbers which are running numbers or continuous numbers, Running numbers or continuous numbers will be a quantitative data. And if we talk about some of the jumping numbers or the discrete numbers, they are usually qualitative. Next is the quantitative data are usually measurable. On the other hand, the qualitative data are usually countable. Mind the word, I'm always saying usually countable, usually discrete, measurable, or continuous. There can be certain overlaps. Let us take some examples. For data from quantitative, let us say quantitative data could be like, let us say we are talking about your weight. Weight could be a quantitative data, your height could be quantitative data, your forced expiratory volume, your sodium levels, your potassium levels, your AST, ALT, all these are quantitative data because they can be any number. But if I talk about number of people who are sick and number of people who are healthy, that's of course a qualitative data. If I talk about number of people who are diseased and recovered, that is qualitative. If I talk about number of people who are alive and who are dead, that is qualitative. If I talk about number of people who are who are Sikh, who are Hindus, who are Muslim, so if I talk about religion, that is again a qualitative data. If I talk about number of people who are boys or girls, again gender is a qualitative data. So you can have n number of qualitative data and the n number of quantitative data. Both the lists are endless. Now let me come to a small point again. What do you think about the pulse rate? Pulse rate of a person. Pulse rate could be 50 pulse rate, 60 pulse rate, 62, 63, 64, 67, 68. But pulse rate is what? Can you have a 60.2 pulse rate in your? No. So what is pulse rate? Is it a quantitative data or a qualitative data? You will get confused. What is it? So mind you, whenever I said that it is usually continuous, discrete or measurable, I always said the word usually. Mind you, what makes in reality a data as quantitative or a data as qualitative is technically, I'm sorry to say, it is not discrete or countable or measurable or continuous. It is that if you can find out, the mean of the variable, if you can write it in big letters, if you can find out the mean of the variable, the answer will be a quantitative data. And on the other hand, if you can find out the proportions of the data or the percentages of the data, write it in big capital letters, the answer will be a qualitative data. Can you beat that? So now, if you understand this, please mind you, in your exams, this is what is going to help you. Nothing else. Don't worry about continuous or discrete. They can always overlap. In fact, the examiners will trouble you with this. These are very simple basic questions. If you don't understand how to divide data, then you won't be able to go ahead in biostats. So at the first level, you need to understand how to divide data. Data can be of two types, quantitative or qualitative. Quantitative data is when we do calculate the mean, and qualitative on the other hand is when we calculate proportion. Let us come back to the MCQ again. What do you think about the pulse rate? Pulse rate in 10 people were calculated. You're going to calculate the percentage or you're going to calculate the mean? You're going to calculate the mean. So simply answer is that what is a pulse rate? Pulse rate is a data which is countable. We count the pulse rate, right? Pulse rate is a data which is countable. It is discrete and it is a quantitative variable. On the other hand, you can also talk about blood pressures. Blood pressures, sometimes you measure blood pressures, and blood pressures are usually not discrete. They are not continuous, they are discrete. You can't have a BP of a person as 122.36 millimeters. We usually, on a sphygmomanometer as well, we usually keep the discrete numbers. So BP is again a discrete data, which is again a quantitative variable. So based on your understanding, just keep it in mind, at the back of the mind, think of 100. That's how I do. So I think of 100 people. In those 100 people, if I calculate that, or if I find out that particular variable, what the MCQ is asking, I find out whether I'll calculate the mean or the proportions, and there you go, you'll get the answer in front of your eyes. So this is one very basic question for you. So that covers our first number MCQ, or the first topic of the day. The next point that you need to do is, what are the scales of data? The scales of data can be broadly classified into 4 types. We can have something called as a nominal data, we can have an ordinal data, or we can have an interval data, or we can also have a ratio data. So there are 4 scales of data. These are, we can call them as N, O, I and R. NOIR, nominal, ordinal, interval and ratio. So what do you mean by all this nominal, ordinal and interval ratio? Let me give you an example and then we are going to see what does it mean. Let us say you're working in a hospital. In the hospital, you're working in a cancer hospital and you get lung cancer patients. Lung cancer patients, you get 20 people. You get prostate cancer patients, you get 20 people or 10 people. You get maybe the breast cancer cases, again you get 16 people, something like this, whatever. What type of data is this? This type of data is a qualitative data. Why it's a qualitative data? Because you're counting people. Of course, it's not a quantitative data and you're going to present it as percentages, right? Everything goes towards the qualitative basket. Let us go into this data. Let us go into the lung cancer. Once I go into the lung cancer, I found out how many people were stage 1, stage 2 and stage 3 of the lung cancer. I found out that 12 people were stage 1, 6 people were stage 2 and remaining 2 people were stage 3. So that is like total 20 cases were there and 12, 6 and 2 type of stage 1, 2 and 3 people were there. Okay. What type of data is this? Data number B. This data is also a qualitative data. Why is it a qualitative data? Because again, of the same principle that you're going to present this data as percentages and it's a countable data. Done? Very good. But there's a difference between this type A data and type B data. What is the difference between this type A and type B? If I want to present this data to you, I will present it as lung cancer, prostate cancer, breast cancer, or breast cancer, lung cancer, prostate, or prostate, breast, lung, whatever I want, I can do. But if I want to present you the B type of data, it has to be stage 1, stage 2, stage 3. It'll be absurd. You'll laugh at me that, look, what is he doing? If I present to you as 3, 1 or 2 or 2, 3, 1, it has to be either 1, 2, 3 or 3, 2, 1. That means both are actually qualitative data, but there is an innate difference. The difference is that in the ordinal data, there is a particular order. The stage 1 will come or stage 2 will come only after stage 1. Stage 1 will always be before stage 2. And stage 2 will always lead to stage 3 or stage 3 will always be after stage 2. But there is nothing, this is absurd, that lung will lead to prostate or prostate will lead to breast. It doesn't happen that way. So lung, prostate, breast, they were nominal data. These are nominal data. Nominal in Hindi means names, naam. So these are names. Mahesh, Suresh, Bhupesh. No one's bigger, no one's smaller. But stage 1, stage 2, stage 3 is bigger to smaller. So there is an inherent order to that. Right? So just 2-3 MCQs that you need to remember about nominal, ordinal and interval. Nothing very big, no rocket science. In nominal data, please remember just one MCQ that there is no sequence. That's all that you need to remember. Just I wanted to explain to you that in nominal data, there is no sequence. Whereas in ordinal data, common sense, there is a sequence. Or the examiner might say there is an inherent order between the categories. So this type of data is called as a ordinal data. Inherent order is there. Next, let us talk about the intervals and the ratios. If I talk about interval data, please remember in interval, very simple. There is only one example, that is degree Celsius. What do I mean by all this? Let me give you an example. Let us say that today it is 20 degrees Celsius in Bangalore and maybe after 5 weeks or in summer months, let us say it goes down to 40 degrees Celsius, right? So you have data example number A in which today it is 20 degrees Celsius and after some time it is 40 degrees Celsius. I'll give you example number B, another example. Let us say a child enters into our OPD and the child was very, very weak and fragile and kind of thing, and the child was weighing 20 kgs. At a particular age group. At the same age group, ideally the child should have weighed 40 kgs, right? What type of data is this? So what is this 20 degrees and 40 degrees? What type of data? Is it qualitative or quantitative? Degree Celsius, it has to be a quantitative because the temperature can be 20.1, 20.2, whatever number. But the weight of the person, what type of data? It's also a quantitative because weight can be anything 20.1, 20.2, 40.1, whatever number. So both are quantitative data, but the point to be noted is that there is a difference between this data A and data B. The difference is that can you pick up this child number, let us say this is C and this is D. Can you pick up this child number D and say that, wow, you're weighing double of the child number C? Yeah, can we do that? But in data A, in category A, if I take X and Y days temperature, can I say that on Y day or in summers it is double? Mind the language, it is double as hot as in winters. Or can I say that today it is half cold as in summers? Do we say like that? Half cold, half hot, or double hot? We don't say. We always say that it is too hot or it is too cold. Why do we say it is too hot or too cold? Because of simple understanding that there is a 0 degree Celsius and there is temperature beyond this also. But there is a 0 kilogram baby and there is nothing beyond. You don't have a negative mass. That means, in simple words, I want to say that the time from this person, this let us say X day, has taken to reach here, whatever number, we don't know this because this is infinite. And the time from here to here, we also don't know. This is infinite. But yes, we do know that the time from this to this is the difference is 20 degrees. Therefore, this difference is important. It is called as an interval data. It is called as interval data. Over here, you know that 0 to 20 kgs is 20 points and 0 to 40 kgs is 40 points. And you know that 40 is equal to 2 times of the 20. So you can say that it is double. This type of data is called as a ratio data. And both are generally types of quantitative data. So just MCQs for you to remember that what is interval data and what is a ratio data. Please remember, anything which is quantitative is usually a ratio data. Anything which is quantitative will usually be a ratio data. Only one example for interval scale you can remember is degree Celsius. I will share with you some more examples, but for right now, just remember this. Let's go and learn what all things you need to remember for your exam for interval and the ratio data. So for interval data, please write down. For interval data, please remember that the interval is important. Interval is important. Whereas for a ratio data, the ratios are calculated. Ratio can be calculated. Next MCQ. In the interval data, please remember that there is no absolute 0 point. That means there is no starting point. There is no start point as you had seen in the degree Celsius. There is no start point or there is no absolute 0 point. There is no absolute 0 point. Whereas in a ratio scale, there is a 0 point and there is an absolute 0. Absolute 0. Beyond which nothing exists. That means there is nothing called as negative. Examples for ratio data could be anything in the world. Examples for ratio could be anything like your sodium levels, potassium levels, forced expiratory volumes, your liver enzyme levels, your cardiac enzyme levels, this level, that level, whatever you want, you can remember that. On the other hand, the interval data, this list is endless for ratio scales, right? For interval data, you have to think of something which does not have an absolute 0. So example 1 would come to your mind is degree Celsius, we already talked. Another example that you can take is decibels. The decibels, that is the unit for understanding intensity of the sound, that also 0 decibel is like having a particular sound at that point. So 0 decibel is nothing but the minimum possible sound that we can hear. And mind you that 20 decibels is not half loud as much as 40 decibels is. The intensity of loudness, if you add 20 decibels to 40 decibels, it may become 40.5 decibels only. So decibel scale is also an interval scale. Degree Celsius is also an interval scale. Another examples for nominal or ordinal data also you can remember. For nominal and ordinal data, what are the examples that you would like to remember? Or nominal data is anything like the type of disease, number of people having breast cancer, lung cancer, so on and so forth. You can also talk about gender. How many are boys, how many are girls, and no one's bigger, no one's smaller. If I talk about the ordinal data, ordinal example would be stage of disease, example would be the grade of disease, example would be the severity of disease. How many are mild, how many are moderate, severe? There is an inherent order. But if I talk about the religion, how many are Sikh, how many are Hindus? That's nominal data. If I talk about the blood groups, blood groups, all these are examples of nominal data. So these are couple of questions that you get in your exam. So first is you see whether it's a quantitative data or a qualitative, and in the next level you talk about what is the scale of data. So with that, we finish this module on the data types, and hello and introduction to the biostats module.